Okay, this example is from your textbook, page 689, number 10. And it tells me that I initially have 0.25 moles of H2 and Br2 introduced into a 500 ml container. It also gives me the Kc value, and we need to solve for the concentrations at equilibrium. So we always start with a balanced equation. 2HBr gives us H2 plus Br2. So this is just from the textbook that I got that reaction equation from. And we can set this up in our ice table. So I have 2HBr reacts to form hydrogen gas and bromine gas. And I know that initially 0.25 moles of H2 and Br2 are introduced into a 500 ml container. So we'll start by converting that value into moles per liter. So 0.250 divided by 0.5 liters gives me 0.5 moles per liter. So we can sub that into our ice table for each of the products. We have 0.5 initially. And it doesn't mention anything about there being any hydrogen bromide present, so we can assume that this starts at 0. In this case, we're not given any information about the amounts at equilibrium, so we can't use that to solve for the change. So in this case, the change is unknown. So because I only have H2 and Br2 present to begin with, we know that the reaction has to take place in the reverse direction. So we're going to increase the amounts of HBr and we're going to decrease the amounts of hydrogen and bromine. Because we don't know how much that is, we can say that the hydrogen will decrease by X amount. Because these are a 1-to-1 ratio, this will decrease by the same amount. The HBr is a 2-to-1 ratio, so if we multiply by 2 over 1, it's going to increase by 2x. So at the end, we'll have 2x, 0.5 minus x, and 0.5 minus x. So we can set up our equilibrium expression to solve for x and figure out the values at equilibrium E. Kc equals P over R. The Kc value was given in the initial question. It's 0.020. My products are both 0.5 minus x to the power of 1. And my reactant is 2x to the power of 2. So we can simplify this to write 0.5 minus x squared. 0.5 minus x times 0.5 minus x equals 0.5 minus x squared over 2x squared. To simplify now, we can take the square root of both sides to cancel out the squared. We have to do the same thing to both sides. So we get 0.1414 equals 0.5 minus x over 2x. We can multiply both sides by 2x to get rid of this fraction. And 0.1414 times 2 gives us 0.2828x equals 0.5 minus x. When we're solving for an unknown like that, we have to collect all of the like terms. So we can add x to both sides to cancel over here. This is like adding 1x. So 1 plus 0.2828 gives me 1.2828x, which is equal to 0.5. And then divide both sides by 1.2828. And we get x equal to 0.389 0.77. Remember, this is not a concentration. This is just the value of X. It's the value of our unknown. So we have to go back to the original question and substitute that value in for X. So 0.5 minus 0.38977 gives us 0.110, 0.110, and then 2x is 2 times 0.38977, so we get 0.780. These are our values at equilibrium in moles per liter.